How's everyone? Thank you, Jim. So, yes, I'm wearing my concert tee, you know, the event tee to the event. I think that's like going to your favorite band's concert and wearing their tee. So, today we're going to talk about multi-cloud security and visibility and how it should be agnostic and awesome. And we'll explain the definition and how that works. And we'll also show you some cool things in Sysdig. So, about me. My name is Dan Papandrea. I'm the field CTO with Sysdig. Been there for the last 3 years. Formerly with HP Helion, worked on our distribution of OpenStack, so IaaS, PaaS with PCF, and the hybrid cloud. Former lead solutionist for an SS&C, which is an investment software company. Was basically a development product manager. And lastly, which makes me uniquely qualified for talking about multi-cloud, is the son of a pizza man. So I woke up, you know, I grew up in the pizza business. So you go to meetups, there's a lot of pizza, right? Agnostic. So in terms of what agnostic is, we all know the term, but basically if you look at it, it's not referring to a particular device or system. So if any of you were at Nova's talk yesterday, you heard about how, you know, basically the cloud and being multi-cloud is, you know, you're utilizing resources that are in like Linux hosts or a bunch of different orchestrators, and you're just putting your applications in the places where they need to be. So you need to ensure you have tools that are agnostic, that are looking into this and being able to give you visibility, and even in guaranteeing a certain level of security as well. Awesome. Hello, I'm awesome. Do I have to define this for you? If I have to tell you, you probably need more awesome in your life. So I'm hoping to help out with some of that. I hope this talk, well, I went ahead of the slide here, but if you guys know the Beatles, I'm hoping I'm here to help you with that. So, the reality of cloud native and multi-cloud is, you know, if you've seen this Dilbert, I'm sure you guys have seen this ad nauseum. I really like it though. It's basically like, if I need to know why we're moving our app to the cloud, it doesn't automatically solve our problems. I won't read the whole thing, but I just love how like you folks are just throwing these terms out without understanding, like, hey, does my application work there? You know, maybe my tools, my legacy tools don't work. And so I have to look at, you know, uniquely new ways to be able to cover this from a multi-cloud perspective. So if you look at the multi-cloud paradigms, if you talk about, like, if you heard when Armand was talking about, you know, all of these different places that you need to dynamically put your applications or services, I mean, there's all types of different places, all, you know, multi-cloud with GKE or AWS or IBM Cloud and all those things. You're going to put them in places that best serve your applications, also if what your developers are used to deploying with. You really need to ensure that you have an agnostic set of tools that are helping you there. Kind of, you think about the premium in terms of the microservices are your default deployment model. If you look at your UI, your applications, your databases, and you're importing those over, you know, there's advantages obviously with, you know, innovation pace and cost efficiency and risk mitigation for moving to these, you know, to multi-cloud or things like Kubernetes or microservices. And as we know, like most of us are looking at Kubernetes as a mechanism, or containers as a mechanism for really speeding up that move. This is the problem statement, right? You cannot secure or see what you cannot see. So that means is cloud native paradigms really leave you blind. Ops really fail without some dynamic context and scale. So understanding like, hey, here, I put this application here. It's not just I'm just having a host and putting my legacy app on it. I'm surfacing, you know, I'm surfacing metrics, or I'm trying to figure out if, you know, who's going into this environment. And also, they're ephemeral, right? Containers and services might go up or down, right? So you don't have that paper trail. You don't really have an event stream to be able to help you there. If you think about legacy or point softwares, if you think about, like, they're not built for cloud native applications, and as you're moving these things over, you can't just port them over and expect them to work. There's no immediate context, like, okay, I've deployed this cluster in AWS that's running this service, that's running, is connecting to an external RDS or something like this. They're not built for DevOps. Also, point solutions have invasive instrumentation or limited context or lack your scale and depth that you need to be able to really make decisions quickly from a visibility perspective as well as from a security perspective. various solutions out here. You know, again, if you've probably heard of or have implemented Prometheus at this point. I think even CockroachDB, they deploy when they're deploying their applications, they immediately export their metrics in Prometheus. You're also going to get vendor tools that are going to provide. They're going to lock you in with specific. And again, if we're looking in terms of agnostic aspects of this, they're going to lock you into specific ways to get those metrics. Whereas you want to be agnostic, you want to be able to take those metrics and do great things with them. And even if you think about the second paradigm of deployment and security, and I put this specifically here. I'm not being bribed by Armand, but I really like the way that HashiCorp does. Like Terraform is just a really amazing mechanism for deploying across clouds and in your applications and what have you. And for identity management, Vault is fantastic. But what Sysdig brings to the table is runtime behavioral and visibility for one agent and one backend. So Nova talked yesterday how we tap into the kernel, and the kernel to us is that underlying. Wow, that's creaky. WD-50 there. Before you fall through there. So basically, is a kind of a default paradigm for getting details, pan any of your clouds. If it's AWS, it's GKE, or and what have you. The other thing is you think about these solutions from a cloud provider has these awesome services for you. They might have a container registry. They might, all of them have a CR, right? There's an ECR, there's ACR, there's ICR, there's all of those types of things. One of the things that we can provide you is also, from a Sysdig perspective, is visibility and troubleshooting. So I kind of want to show some of that. So I deployed a cluster in GKE, but I can show you one that is a multi-cloud deployment here. So here's where I have a bunch of hosts, and I'm looking at this, and I'm like, okay, here's a GKE cluster, AWS cluster, IBM, some others. If I just want to look at this in the old way from a legacy perspective, and I just want to understand, like, okay, here's my GKE cluster, here's my CPU, and what have you, but look, we're sharing services. We might do this cross multi-cloud. We might want to have this service speak to this other service. But we want to see that, we want to understand the context. So now I want to group these by, for instance, clusters and namespaces. So now I understand that I have this application. And again, you're probably deploying applications in a single cluster in a single cloud paradigm. You're probably using AWS or GKE or what have you. But I'm just showing you this is showing you like it laid out by cluster. Then I can see here's my namespace here. And here's my deployment, and these are the various processes, these are the various things. So now I'm singling it out and getting the context of where this is. So I can do some things like this, where I can say, what's my network traffic for these things talking to each other. And so all I've done is, in full disclosure, I've just deployed our agent as a daemon set on these hosts. And so now I can see, for instance, this worker process all the way down to this voting process that's connecting into the DB. It's connecting into the various things. So this is almost like a map, right, for a topology map for your environment here. You can also get, and I'm gonna use my words. I'm gonna use my words here. I'm kind of flustered because Liz the Gray is here, and she's one of my heroes. So I learned a lot about golden signals just reading a lot of the documentation she has. So please don't rip me apart on this one, Liz. I'm just doing this. So if we look here, is in terms of specific golden signals details just for this. I'm not just looking at it at the host level like I showed you before. I'm looking at it in the context of my application. So I'm seeing what my response times are for that. I'm seeing the request rate. I'm seeing where my net errors are. So I can really make an informed decision on how my CPU usage is being used and how, and all of my resources are being used. Because that's the whole promise of it is, again, we're looking at this not like holistic, where we're only getting one cloud provider's look of this. This is pan provider. Is it making sense? Back to slides. Any questions before I move forward? All right. So again, the other things is the whole monitoring and performance and capacity, like understanding and then troubleshooting issues. We can also, the other thing that we can do with our agent is do security. So what this means is from your build, and then your run, and then your enforcement. So this means if I have deployed in real time an application like that example voting app I showed you earlier, or I'm using CockroachDB, for instance, and I've gotten this image from the, just from the container registry of some sort, I've scanned it. That's one part of this whole security journey. I want that context. I want to understand, like here, I want to understand, like, this application is sitting here, and this service is being deployed in this environment. I want to be able to answer these questions. How many CVEs are deployed? Did a user access a container in a namespace? How much of these services, what's the consumption specifically for that service? So it's not just, again, from a multi-cloud perspective, we're just looking at this holistically based on all of our applications being deployed. So just to let you guys see this, I basically deployed CockroachDB in a couple of sample applications here. All right, and what I want to do is I deployed this on this GKE test cluster I had here, and I can see it's here. And if I just want to go here, all I've done again, all it's in this environment is I've installed our agent. So I look at this from a runtime perspective, and I look at our CockroachDB. And again, remember that context. Again, context is king, queen, rook, all the horses, all the men. You need context to be able to set these policies, to be able to say, this cluster, I want this image to, I want this policy to be in play for this image running on this cluster in this service, that type of thing. Now I look at this, and the coast is clear, right? Green's here, it's passed. There's a warning, but it's okay, my image is scanned. But does that make me secure? Well, let's see. So again, just taking off of what Nova did yesterday, talking about we have this concept of Falco. We're tapping into the kernel through a function of what's called eBPF, which is a native function of the kernel, to be able to tap in and show you like events that are happening from that perspective. So even if I'm running a node in any of those public cloud providers, we're able to take action. So here's what I'm going to do here. I'm going to go into this CockroachDB namespace, and I'm going to kubectl, 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 whatever you call it. I just use a K. I make it easy. I'm agnostic. I'm saying everything works there, right? So what I'm going to do is I'm going to exec into that pod. Liz, you're still making me nervous up here, so. So I'm going to go into that Etsy. And so what we do here is we have a policy that we've defined here in our policy events. And we have this rules library, very similar to what Nova showed yesterday, where it's like, okay, I have all of these events, but now I have a UI that I can interact and make outputs and what have you. So that's how we utilize the IP of our investment. So there's a CNCF project called Falco that Nova's in charge of, and basically that is a project that provides, like, again, behavioral and runtime rule set. So let's look at this Etsy. So if anyone writes below Etsy, there's output being used here, and if I look at my library, if I look at my runtime policies, I can have it do an action of some sort. Rule Etsy here. And all of these come out of the box Sysdig, so you don't have to create these or whatever, and these are extensible. Is that the term? Okay, so again, son of a pizza man. So if you look here, we see writing below Etsy, we can stop a container, we can have it linked into an admission controller, and again, we're agnostic, so we can, if we're using something like Kubernetes is running, and we're not using the conventions of the public cloud providers method for doing it, we can if we want to. If you hear of Grapheus or Credis, and those are PAN solutions as well. We do something similar. But then here's the difference. So our founder, Loris Digiani, is one of the guys that was one of the key developers of Wireshark, TCP dump. So I'm going to take a capture, a very single system call that happened when I went into that directory and wrote to Etsy. And then I can send a notification to your typical, places like Slack, SNS, any of those. But again, I'm not going to a specific channel. I can make it anything I want, being agnostic. So I'm in this Etsy directory, and I want to VI. Is that hidden? Great. Here we go. So I want to VI escape 19.txt. Insert, I say, I hacked your DB. Okay. And I'm going to exit. So again, remember I asked you guys, is that container secure? Image scanning, you're only 1/3 of the way there. We do it, but now, if I go here, what happened? It saw that I terminal, and look how quick that was. I terminal into container. I wrote to Etsy, but then it showed me the context that I was in. Think about this. If I have hundreds of containers running, or excuse me, hundreds of nodes in a cluster through multi-cloud deployment, how do I know which one this happened on? So now I look, it says right below Etsy, and it gives me the policy violation events. It's showing me that's the cluster name this happened on, which is that Sysdig Escape 19 cluster. It's showing me the namespace. It's showing me the pod name. It's showing me the container ID. If I was running this on a logical host, it would show me just the host level detail, like you're seeing here, the ID, the image that was there, and then it's also showing me the commands that were written. Now, I am root. You guys are looking at me like, oh no, why? So if anybody, hopefully your security people aren't, there's no, show of hands, is there any security folks in the room? Don't slap my wrist, I'm sorry. It's a demo environment, thanks for the thumbs up. So now you can see like the user ID is 0, but I can have that information so I can understand who came in and what they did. So now I have the command that was written, but this is where we can use our capture to get even more detail. So what you're seeing here is a capture of every single system call that happened on that host. And there's a timeline, 0 to 20 seconds, because remember it was 10 seconds before the event and then 10 seconds after. So in that timeline, it happened at this point. Some commands were run, and then there were some modified files. So I'm going to go into that time frame and go all the way down to the millisecond that happened. So instead of 70,000 or 80,000 system calls, I'm going to go down to 9,000. And I'm going to look at my modified files here. And I can see that this is the one that's here. Swap. So this shows me like what was written to, and it shows me the actual text file and itself. So this is showing you kind of the output that you would have here. So it's giving you that level of detail. So again, what Sysdig can help you with from a workflow perspective is helping you from a CI/CD perspective. So again, we're scanning. We can integrate with your various registries of them sorts. Even with Quay or JFrog if you're using those things from an image vulnerabilities perspective. Metrics and events. So if you think about your services in the context that we provide, but also if you're surfacing any of your metrics, be it Prometheus and StatsD and JMX, we're also picking those up as well. So again, visibility is keen on that. And also those security policies. You can then take that data and then inform some type of event stream. So if you think about it, it could be like syslogs, downstream SIMs of some sorts, and even response and remediation. So I did a webinar recently with a service mesh company. And what we did was we had one of those events where writing to Etsy or terminaling into container had it so they would actually have their traffic and some of their networks basically move from service to an external service. So they were able to use, in real time, being able to, the very detailed kernel specific detail to be able to write an automation and mediation step that way. So it's pretty cool. This instrumentation point is a very unique data point, being, the kernel and system calls. We can deploy this, and the last thing is this can be deployed via SaaS in our own SaaS, or managed SaaS, or self-hosted within your environment. So if you don't want that's protected, in your specific clouds, we can do that for you. So my last slide, and I'm really, I think I'm early, by a lot. So the platform, again, what we do from an agnostic, what our platform does is we help you deploy your application securely. We can help you block threats at runtime. We help you from that remediate and respond. So if you remember when we had that command audit, the way we're able to integrate with that. Also that full stack of visibility, we're able to integrate via your hosts, your services that are running on said hosts, run reliably at scale, and then help you troubleshoot issues, because you can utilize this tool to be able to create captures, to be able to do things like troubleshooting DNS issues as well, and those types of things. If you want to play around with Sysdig, if you want to understand what it does, Sysdig.com, you can request a demo. And again, all of our tools are based on an open source foundation. So meaning, if I want to, if you want to, extend functionality, if you want to add things like rules and seeing what we have this, falco.org is our site for adding rules and what have you. And that's something like, again, Chris Nova is fronting. Is there any questions? So the question is can this be utilized with existing on-prem services? Absolutely. So again, since we're tapping into the kernel, we have the function to tap in to be able to look at visibility of processes that are running on said host. One of our largest implementations is one of the largest investment banks in the world, and what they're doing is they're utilizing us to be able to track the risk jobs. The jobs are being sent out and scheduled, and they're running, and they were using a polling mechanism previously, versus having us at that real, very detailed, granular, function to be able to extrapolate the proc to network connections ratio that quickly. Any other questions? In the back. I'm sorry, could you speak up? Thank you.
So, can can this one be checking the S3 ones? Like, if I accidentally deleted a file in S3, something Amazon services, so you can go there and check it too.
Sure. So here are the services that we do integrate with. Basically, we integrate with CloudWatch metrics and tags and what have you. So, for instance, here's these clusters. These are the specific services that we can integrate with: RDS, DynamoDB, Elasticsearch, and what have you. But if you're surfacing things within like CloudWatch metrics detailed, we'd be able to parse that detail in as well. I'm sorry I didn't repeat the question, but basically was asking if we integrate with any of the AWS services. But again, in the crux of being agnostic, right? It's like like if you are utilizing those services, and let's just say that and again, it depends. Like, I want to make sure that like if I was deploying applications, they're going to places that are the best benefit for my application. So AWS is great. Maybe I'm putting stuff in Google. Maybe I'm putting stuff in here. I don't want to be locked into a specific methodology, right? I want to kind of abstract that. Here's my DB, and I'm adding tables. It doesn't. I want to be able to put it anywhere, right?
All this data is Sysdig
Mm-hmm.
captures. Is it stored in like SaaS or in like on-prem or?
So those captures are only done for two ways, or three ways. One, if I manually target a capture, I can go ahead and do that. Secondly, if I have an alert, and so we have alerts that we have in our, if you look in our product here, so from an alerting perspective, you can create APM level alerts, Kubernetes specific alerts, and what have you. And from there, I can create a capture, get notified, and then create a capture. And then the third function is what I showed you from a security perspective, where I was able to, when there was an event, I'm not capturing all the time. There's this ring buffer that happens. I'm only capturing if an event happens. So think about this. I'm a compliance person at a bank or a federal agency of some sort. They're asking me, I need to know what happened between this time, 4 o'clock and 4:05, because somebody came in and dropped a directory here. I'd have to go into, maybe I've stored everything in bash history, but I still have to go in and look through that, versus if I had one of these rules in place and said, okay, I have a sensitive directory that I'm monitoring, or I have a specific container or service that I'm trying to integrate with, then I can get that moment in time. I don't have to search through reams of commands to be able to figure out what happened. I'm sorry, I got you. I'm going to finish this.
The policy for that etc file, where is it enforced? On the container or the data?
No, it's
somewhere and somewhere.
so the policy is done via the agent. The agent is installed on the host itself, and nothing is. That's the other thing. It's done at the host level. We're tapping into the kernel to be able to do that. So nothing is instrumented within your containers themselves. It's all at the host level and tapping into the kernel. And in terms of where that data resides, I'm going to get to you, I promise, I swear. Basically, where that data resides, that could be an on-prem implementation. Let me just show you that slide just to make it more clear. So you see here, so it can be on-prem, self-hosted, meaning you can do it within a VPC of your own choosing, and then SaaS, right? So we can do it for you. So it's all stored there. I mean, again, I get the question all the time is, well, how big are these captures? And they run like, I've seen one that's like a 30-second one go for like maybe 50 megs, if that. And if you're scaling your app, if you have our backend and we store it indefinitely, but it's all based on how much storage. It's all stored in Cassandra, right? So it's all available there. Finally getting to you.
My turn.
You got the mic.
I have
It's
two
your boat.
questions.
Sure.
First, a very simple one. What is the performance overhead of running these? Secondly, from my understanding, originally, most of this stuff was captured in using a kernel module. Now you're using BPF
Yep.
for most things. And I think that was a change because there were some compliance issues in some cases.
Yep.
Are you seeing any pushback for, like when you explain to this, that you have this little process that runs in like a little virtual machine in the kernel and has kind of a lot of access? Do you see any resistance to that as well?
Yeah. So the first part of your question in terms of agent overhead, the agent itself is where it's a C application. So the way that we've architected in such a way, again, Loris has been doing kernel-based tools and agents for X amount of time. So that's how we have it deployed. It's very low overhead. I've seen it peak to maybe 2 to 3% of CPU. But since it's a daemon set, you can cap the amount of resources that are available to it. So that answers your first question. In terms of the second question, so we do have the kernel mod function, and we also have the eBPF function. And so what customers say to us is, okay, if you're able to give me this glut of data, and that's why, again, using our secure product, we can only allow a specific kernel KO that's available that we can have. So if it goes beyond that, it's the same thing. If you were deploying like an NVIDIA GPU level driver, you're still having to compile something that has to interact with the kernel. And so the way that we get around that is just justified by basically the amount of functionality we're able to provide, and then also using our Falco rules to be able to kind of self-police what can happen with our kernel module. But again, if you think of eBPF, those functions are already there in the kernel anyway. We're just tapping into those. And customers that are using our sysmod probe, with that's a kernel that's lower than 4.14, we just use our sysmod probe, and they're fine with it based on what they can do with our full platform. Great questions. Any other? Yes, sir.
You probably answered this. For PaaS solutions, how do you, this is agent-based, right? So the PaaS solution, like SQL, Azure SQL DB, for example, how do you capture kernel level for that?
So are you asking for monitoring like SQL, like MS SQL or like MySQL? Yeah, so so the question is how do we look for database services? A lot of these are again, if you think about it, they're being surfaced within a Prometheus metrics of some sort. But I mean, I'll give you an example where we're able to do like TCP assembly and disassembly to do some unique things. So what we can do here is, here's a database that's part of this application here. And yes, it's this one. So you can see there's a DB that's part of this. So if I look at this from a Postgres perspective, here, we can look at the queries that are available in there. We're not getting a PII data, we're just getting the actual queries themselves. We're looking at our slowest tables, we can get our request types. And so we're using what we call app checks to be able to look into the container themselves. And again, we've installed nothing within the container or the DB to allow that level of access. We're just looking at view tables to be able to do that. Any other questions?
All right. All right, thanks, Dan.
One last thing.
Were you going to play some music for us?
No, it was all right. No, don't worry, I'm good. I finished.
Oh, come on.
No, it's cool.
I love one last thing in a presentation.
No, it's cool.
It's very Steve Jobs of you.
I know. Yeah, and by the way, it's free. No, it's not. I didn't say that out loud, sorry.
But that's on tape.
It is.
Send
Oops,
that to
it's
Jameson.
not free. All right. Thanks everyone for your time. I appreciate it.
Thanks, everybody.